Okay, in this demonstration we're going to look at the infamous iodine clock reaction. Now there are several recipes for these ingredients. The one that you'll probably use is in the classic chemical demonstrations handbook the Royal Society of Chemistry produce. If you want to know what's what, this is a complicated set of reactions. We've simply got a two-solution base here. We have solution A, which contains both potassium iodide and sodium acetate, with a little bit of ethanoic acid in it, a bit of acetic acid in there, and some soluble starch. Getting the starch to dissolve is the tricky part for your technical people. The other solution, solution B, for want of a better term, is 5% hydrogen peroxide solution. And what I've set up here is an experiment to show the difference in concentration has on rates of reaction. So in our big 400 beakers at the front, I've got 2 lots of solution A, the potassium iodide, etc. mix. I've got solution B in the 250s either side. I've got 150 of the solution B, the peroxide, and I've got 100 mils, 100 cubic centimeters in the other one, and 50 cubic centimeters of water. So we'll keep the one on my left-hand side notified by the water bottle as the more dilute of the two solutions. And the whole idea is we'll start the reactions at the same time and look to see what happens in terms of reaction rate. You could, of course, use a stop clock if you wanted to do these one at a time. So let's start them off together. Simply mixing them from heights should actually stir them sufficiently. Now, while you're waiting on these results, and it will take a moment, as you can see there, the concentrated one has gone quickly, followed by immediately afterwards the more dilute one. You'll need to be discussing with your students why that should be. Remember, the students forget that water is a chemical. There are molecules that are getting in the way. If you have far more concentration, if you have far more water molecules, molecule A, whatever that happens to be, is less likely to collide with molecule B with sufficient energy to cause a reaction. If the water molecules are in the way, it's not going to allow that to happen. However, you can explain that in your own words. The solutions here are blue-black because of the iodine formation. Iodine chucking down into a white sink is not a good idea. So what we do here is that we've got a solution of sodium thiosulfate. The thiosulfate solution is saturated. You can see some crystals in the bottom there. And we simply use this to get the iodine back to the iodide ion by reaction. If you haven't got a big enough beaker, you can simply use the crystals, and because it takes the time for it to dissolve and then react, it will take a moment or two.